Next topic is the detection of the periodic signals in the presence of noise by the correlation. The detection of periodic signals can be done in the presence of the noise is one of our greatest importance. It finds the applications in the detection of the radar and the sonar signals. Generally, the noise signals is uncorrelated with the specific periodic signals. The noise signals is different, which is randomly present, which will not having any correlation with our periodic signal. That periodic signals can be represented in the mathematical form, whereas this noise signals can be always been random, which cannot be represented in our mathematical form. Therefore, when we take the correlation, that is the similarities between this noise as well as the periodic signal, therefore its correlation value will be said to be 0. That is, S of t is the periodic, N of t is the noise. Therefore, the cross correlation function of the both of them is Rsn of tau is equal to 1 by tau from minus t by 2 to t by 2. S of t, N of t minus tau dt will always be said to be 0. Now, as there was no correlation or no similarities between them, therefore detection by the autocorrelation, let the S of t will be the periodic signal mixed with the noise. Therefore, the received signal, which is also periodic, therefore our y of t will be nothing but our S of t plus N of t. Therefore, the autocorrelation between of the signal y of t, that is Ryy of tau is equal to 1 by t from minus t by 2 to t by 2 y of t minus tau dt. Therefore, what is y of t? It is the mixing up of the periodic signal S of t and the noise signal. Therefore, we'll write y of t as S of t plus N of t, and y of t minus tau as S of t minus tau plus N of t minus tau. When we simplify that one, we'll get the 4 correlation functions. That's Ryy of tau is equal to Rsn of tau, Rsn of tau, or Ns of tau, or Nn of tau. In this, the opposite correlation functions will be the 0. That is, Rsn of tau and Rns of tau will be 0. That's Ryy of tau is equal to Rsn of tau plus Rn of tau, where S of t is the periodic and N of t is the periodic function. As S of t is a periodic, therefore its corresponding autocorrelation function is also periodic. That is, Rss of tau is also periodic. Whereas N of t is random in nature, therefore Rn of tau will be very small for the very large values of the tau. That's the very large values of tau, its values will be very small. Hence, for the very large values of tau, this Ryy of tau is said to be periodic, which is equal to Rss of tau, where Rn of tau will be negligible. Therefore, S of t is said to be detectable in the presence of our noise signal, where this autocorrelation of the noise will be negligible at very large values of tau. Therefore, R will get Ryy of tau will be equal to Rss of tau. As it is periodic, this particular Ryy of tau is also periodic. Hence, as it is periodic, therefore our y of t is equal to S of t, a periodic signal. A periodic signal is detected. Periodic signal is said to be detected. And the next topic is the extraction of noise in the presence of the signal by using the filtering. That the signal can be masked by noise, that the noise can be present in our signal. The signal can be masked by the noise. Therefore, we need to detect the particular signal using the filtering. Generally, there is a one particular relation between the correlation and the filtering. There is a one particular relation between the correlation and the filtering. Let the x of t whose Fourier transform as x of omega and the y of t whose Fourier transform as y of omega. When we take the cross correlation of these two signals, that is x of t and y of t, that's Ryy of Rxy of tau, whose Fourier transform as x of omega into y of minus omega. That the first diagram shows that the cross correlation operation between x of t and y of t, therefore the output is nothing but Rxy of tau. Similarly, when we show it in the frequency domain, the x of t whose Fourier transform as x of omega and y of t whose Fourier transform as y of omega, and we have taken it as the y of minus omega. Then when we perform the filtering here, then again we'll get the cross correlation between the x and y. That means the output is the cross correlation which modifies our x of omega by using this transfer function y of minus omega. Y of minus omega will act as a transfer function which will modify our spectral components as x of omega and produces the output, which is nothing but our cross correlation between the x and the y. Basic concept is that one. We use that particular concept for detection of the noise using the filtering. Let us consider detection by the filtering. Let us consider that x of t and n of t be the desired periodic components and the corresponding random components which are being combined together as y of t is equal to s of t plus n of t. The periodic components of s of t found in y of t can be found by correlating the y of t with the another signal L of t. The periodic components of the s of t can be found in y of t by considering another signal with the same characteristics of the corresponding s of t. That is, we'll consider the another signal as L of t with the same characteristics of the same characteristics means same period as that of the s of t. Therefore, L of t is said to be periodic, whose Fourier transform as L of omega consists of impulses located at omega is equal to 0 plus or minus omega naught plus or minus 2 omega naught plus or minus 3 omega naught and so on. And also the L of minus 1 omega is also located at these frequencies only. That is at omega is equal to 0 plus or minus omega naught plus or minus 2 omega naught plus or minus 3 omega naught and so on. It is obvious that the transfer function L of minus omega represents the system which attenuates all the frequencies except at omega is equal to 0 plus or minus omega naught plus or minus 2 omega naught plus or minus 3 omega naught and so on, like that. Therefore, which indicates that the output consists of the frequencies components at omega is equal to 0 plus or minus omega naught plus or minus 2 omega naught plus or omega naught 3 omega naught. At these frequencies, all the frequencies will be passed, and the remaining frequencies, all the frequencies will be attenuated. That is, the operation of the cross correlation is equivalent to the filtering in the frequency domain. That whatever the cross correlation operation will be present will be done by passing the frequency components at these locations. That is, omega is equal to 0 plus or minus omega naught plus or minus 2 omega naught plus or minus 3 omega naught. These frequencies will be passed, which is nothing but the filtering process of getting our x of omega as like this. That means it will passes the frequency components of y of minus omega. It will passes the frequency components of x of omega at the places of omega is equal to 0 plus or minus 2 omega naught plus or minus 3 omega naught and so on. Therefore, output is the cross correlation function, which therefore this cross correlation function will be equivalent to the filtering process. That is extraction of the noise by using the filtering process in the presence of noise. Thank you.